Hey guys, these are the notes for 1.5. 1.5 deals with solving equations and inequalities by graphing. So essentially, we're going to have two equations equal to each other, and then what we're going to do is we're going to graph both of them, and then where they intersect or where they meet will be our solution for the graph. Okay, so that's when we solve equations. When we do inequalities, it's going to be a little different. So we'll get to that when we get to that point. Okay, but the first one is use a graph to solve an equation. Okay, so right, we have a graph here and a graph here. So right, we can write y equals negative 3x plus 20 and y equals 5. Okay, the easiest one to graph is y equals 5, right? It's a horizontal line at 5. Right, so this is y equals 5. Okay, and then the next one, right, we have negative 3x plus 20. So we have plus 20, right? Here's 1 point. That is our y-intercept, right? And then we have a slope of negative 3. So down 3 to the right. And so negative 3 is down 3 to the right 1. So, right, if we keep going down 3 to the right 1, our next one would be 15. Sorry, 1, 17, right? And then down 3 again would be 2, 14. Down 3 again would be 3, 11. Down 3 again to the right 1 would be 4, 8. And then down 3 again to the right 1 would be 5, 5. Okay, and right, you can see we wanted to find the y value where they matched up, right? We know the y equals 5 is always going to be on 5. So the only really possible intersection is where y equals 5 for our other graph. Okay, so that's why I kind of skipped the other points. Right. And then I'm going to draw my graph. And we can see that intersection of 5, 5. And now to write our solution for these two problems, what we're going to do is we're going to use that intersection and that x value at that intersection. So the solution is the x value at the intersection of the graphs. Right, so in this case, right, our x is 5, therefore x equals 5. Okay, so that's a problem where we have two lines, right? Now this next one, we'll see that we have one line and then we have an absolute value function. So I'm going to rewrite them, right, as y equals absolute value of x minus 4. And then y equals the other side, which is 1/2 x plus 1. I think the easier one to start graphing with is that y equals 1/2 x plus 1. So let's graph that. It's got a y-intercept of 1. So just be wary of the graph, right? This one, it goes by 1s for each small block and then 4s by the other ones. Okay, now this has a slope of 1/2, so we go up 1 to the right too. All right, so we can kind of continue this graph like this. And like that, right? So this is our y equals 1/2 x plus 1. Now it's time to graph our absolute value of x minus 4. Now remember, right, we've done transformations. So if we think about our original absolute value of x, right, it's a V shape, right? Start with vertex 0, 0 and going up 1 to the right 1, up 1 to the right 1, right? It just makes a straight V. Well, we know this minus 4 inside tells us that our h is equal to 4. So we're just shifting right 4 from absolute value of x. Okay, so we're just making our vertex 4, 0 instead of 0, 0. And right, our slope, everything stays the same. We're going up one to the right one, up one to the right one, so on and so forth. So we're just going to continue this graph. All right, and then we go up one to the left one. Right, and we go through there. All right, and I'm just reiterating, all you really need to see is those intersections, okay? So, right, again, our solutions are where they intersect, so we're going to figure out those points. This one over here is at 10 and 6, so 10, 6. And this one right here is at 2, 2. Okay, so if we look back to our part A, it says solution is the x values at the intersection of the graphs. Well, our x values are x equals 2 and x equals 10. Okay, guys, I'm gonna have you guys try this one on your own. So I'm gonna have you pause it right now, try part A, okay, on your own. Then I'm gonna go through the whole solution, and then you'll try B after we go through this on your own, and then I'll give you the solution for that as well. Okay, so pause this, try A, and then play it. I'll go over it, and then we'll go on to B. All right, so hopefully you paused and tried A. Right, we're graphing two equations. So y equals 5x minus 12 and y equals 3. Easiest one to graph is 3. Oh, that's a bad line. Ugh. Sorry, that's not the best line, but y equals 3. Now we have negative 12 for y-intercept. And then we're going up 5 to the right one. So up 5 would be 7, 1. Right. Then up 5 again would be negative 2, 1. Sorry, 2, negative 2. The other one was 1, negative 7. Sorry. Then up 5 again. Right. So we'd get 3, 3. Right. So we can see this line is going to go through the y equals 3 at 3, 3 as our intersection. So our solution is just x equals 3. Okay. Now this is part B. I also want you to try this on your own. So please pause this, try this on your own, and I'm just going to show the solution. I'll kind of go through it too as well. So pause this, try it on your own. Okay, so here's the solution to these equations, right? So the first one, right, is y equals negative and then x minus 2. So, right, you know that negative sign is a reflection over the x-axis. This negative 2 is h equals 2, so we go to the right 2. Right, so you can see, oh, sorry. This should be blue to match that graph. Sorry about that. Let's re-go over it. All right, so that blue one, right, you can see it flipped over, so the V is not going up anymore, it's going down, and then it's moved to the right 2, so your vertex is at, you can see it's at 2, 0, right, that vertex. Then the next one, right, is just graphing a line, so y equals negative 1/2 x minus 2, so you have negative 2 as a y-intercept, right, which is also an intersection there. And then you have a slope of negative 1/2, which is down 1 to the right 2, or up 1 to the left 2. Right. So you should see that we have an intersection here, and those intersections are at 0, negative 2, and 8, negative 6. And we write the solutions as our x values at those intersections, so 0, 8. All right, I just want to go over one more type of problems where we're setting them equal to each other and solving. This one's a little more difficult. This you might see on Math Excel, so I just wanted to go through it. All right, so we have, again, y equals 1/2 times x plus 1 plus 1. All right, so we have a compression, right, with a equal to 1/2. And then we have h. Okay, so h is -1 and k is 1. Right, so we're shifting our graph. Right? We can see our vertex is going to shift to the left 1 and up 1. So we can make our vertex. So to the left 1 and up 1, right? Our vertex is going to be here. Right? Our V shape is still going to go up because we know it's a positive A, but it's going to be a compression. Okay, so what we need to do is test points for this one. Okay, so you're going to pick an X value to plug into this whole equation, and you'll get a Y value. Right, we only essentially need 2, right? We can pick, I'd pick X equals 0 and -2 because, or actually it might be easier to use 1. So why don't we pick X equals 1, right? We substitute it in and we'll get a Y value. So 1/2 times absolute value of 1 plus 1 plus 1, right? 1/2 of absolute value of 2. So we get 1 plus 1 equals 2. So 1 point on this graph will be 1, 2. Now we'll use x equals -3. And you'll kind of see the pattern where we get 1/2, -3 plus 1 plus 1. Oh, you get 1/2 of absolute value of -2. Right? We know the absolute value of -2 is +2. So we end up getting 1 plus 1, which is 2. And we get -3, comma 2. So we plot those 2 points. Right? So 1, 2 will be here. -3, 2 will be here. Right, and I'll continue. Okay, and then the next one we have just absolute value of x. All right, this one should be pretty easy to draw. Right, y equals absolute value of x. Right, so that has 0, 0, 1, 1. And we know our V shape looks like this. Crosses up. And you can see there's 2 intersections. Right, so let's mark them. Right, this one is at 3, 3. Right, and this one is at -1, 1. Okay, so our x values, we have -1 and x equals 3. Okay, so now example 2 works with inequalities. Okay, so essentially our first steps of graphing both sides and setting them equal to y is going to be the same. And then eventually what we're going to do is we're going to look at the inequality and figure out where a certain inequality is either greater than or equal to or less than or equal to the other equation. Okay, so again, our first step, right, we always want to set both sides equal to y, right? So we get y equals x plus 3, and then we get y equals 7 minus 3x. Right, and then our next step is to graph them. Then graph. Okay, so x plus 3, we have 3 and then 1. And then we go down. Right, the slope is 1/1. Okay, so there's our y equals x plus 3. Right, and then our next part is drawing the second graph, right, which is y equals 7 minus 3x. So our y-intercept, right, is b, and this is our slope, right? It's just written in a different form, right? So we're going to plot at 7, and we have a slope of -3. So we go down 3 to the right 1, right? And then we draw our graph, okay? All right, so we have now an intersection, right? Our intersection here is at 1, 4, okay? So now, right, what we're doing is we're going to look at values, right, above this x value and below this x value, okay? So when we go to the right of it, right, and when we go to the left of it, sorry, not above or below, sorry, to the right and to the left of it, okay? So, right, we're going to state which x values, right? So we're going to state which x values, right, make y equals x plus 3 greater than, right, so greater than y equals 7 minus 3x, okay? So essentially what we're going to do is we're going to find out where x plus 3 is above the graph of 7 minus 3x, okay? So where or which interval, right, for x is the graph of x plus 3, right, above 7 minus 3x. Okay, so we're finding out where it's above. So we can see, right, the intersection is at 1, right? So as we look to the left of 1, right, as we go left, we can see the blue graph is below that red graph, right? So if the graph of y equals x plus 3 is below it, right, that means it's less than. So we're not going to use going to the left, right? So not going to use this, right? This is below, so we don't use. Now, right, if we go to the right, or x is greater than 1, right, we can see this blue graph is above red graph. So blue is above red. So if it's above red, that means it is greater than at this point. So any x value greater than 1, this y equals x plus 3 is going to be greater than 7 minus 3x. So interval or a solution, right, will be x is greater than 1, meaning every x value greater than 1, the graph of y equals x plus 3 is going to be greater than the graph of 7 minus 3x, right? So it's above that second graph. So where it's above essentially is where it's greater than. If we were looking for less than, obviously it'd be where it's below. Okay. And if it was like greater than or equal to, right, we'd include that 1, so it'd be x is greater than or equal to 1. But we just are looking for greater than, so it's whenever x value is greater than 1, the y equals x plus 3 is greater than y equals 7 minus 3x. Okay, so I'm going to do one more example. Okay, so this last example we're going to do, right, same thing as usual, right? Y equals 2 times absolute value of x plus 1, right? And then we get y equals 3x. Okay, the easiest one to graph obviously is y equals 3x. I'll make this one red. Okay, so it has a y-intercept of 0 and a slope of 3. Right, so there we go. Next one is y equals 2 times absolute value of x plus 1. Okay, so our vertex is moved up 1 because we have a k equals 1. So we're up 1. So our vertex is 1, 0. Okay. To remind you, right, your vertex comes from h comma k, right? So our h is 0 in this point, right? And our k is 1. So that's why you get 0, 1 for that vertex. And the vertex is where the absolute value changes from increasing to decreasing or decreasing to increasing, right? The end of that V shape. Now we have a vertical stretch of a equals 2, right? So, right, we can plug in numbers for x. So say we say x equals 1, right? We get 2 times absolute value of 1 plus 1 equals 2 plus 1 equals 3. So we get 1, 3. And then say we plug in x equals -1, right? So then we get 2 times absolute value of -1 plus 1, which again, you just, it's almost like a reflection over that axis of symmetry. So we get 2 times absolute value of -1, which should be 2 plus 1 equals 3. So -1, 3. Right, and you know it should make a shape like that because it's a V shape. Okay, so we get 1, 3, -1, 3. And you can see it's going to cross here. So we do have an intersection, right? Our intersection is here at 0.13. Okay, so we have that intersection. And now, again, we're looking for when our 2x plus 1 is above 3x, okay? Above and equal to, okay? Because we have the equal sign. So, right, if we look to the left, right, we can see that our graph is above the red graph, right? The blue graph is above the red graph. That's what we're looking for, and that's when x is less than or equal to 1. Now, as it goes to the right, we can see the red graph is actually above the blue graph. So no, right? This is below, right? So it only works for every x value that's less than or equal to 1 for this 2 times absolute value of x plus 1 when it's above or equal to the graph of 3x. Okay, so that means our solution is x is less than or equal to 1. So meaning everything starting at 1 and to the left is when that blue graph is above that red graph. But anything to the right of x equals 1, right? So x equals 1, x equals 2. You can see the red graph is going to be above the blue graph. So it's going to be greater than at that point. So we're only looking for when the blue graph is greater than. So therefore it is when x is less than or equal to 1.